Hey everyone, welcome to NTDRacing. This is going to be part 2 of the steering system for our desert race truck we're calling Lefty. It's got to be done in about 2 months, so the race is on. Anyway, if you saw the last video, we did the whole slider system and I showed you all the CAD and all the dimensioning for that, so you might want to go back and watch that video. But this video is going to be how we're mounting the steering box into this part of the chassis, how I'm making the pitman arm, and we'll finish out the steering so we can get on with the lower A-arms. Let's go ahead and get to this build. So what we call this here is, now this is the old pitman arm from the Chevy Silverado. You can see that we cut it off. And what we're going to do is we're going to take the grinder and we're going to grind this thing down into something that we can use and weld to. What I'm going to do is, first off, is take this kind of lip off. I'm going to make it totally flat. I'm going to make it like a teardrop kind of shape. And then what I'm shooting for is the same thickness as one of the rod ends that we'll use to basically connect this thing to that slider. So now I have the steering box mounted on my super cool HelloFresh box piece of cardboard here. And what I'm going to do is I'm going to try and scribe the dimensions. So what I did is what I think is the line of the steering box, I lined it up with this red line. I kind of used my speed square on the center of that shaft on both sides to make sure that this thing was normal with the box. And then what I did is I kind of took one of my little boy's pencils, I broke it in half, made a little pencil nub, and I'm kind of just sticking it in those holes because I really can't get my fingers in there. And then with a pair of pliers, I'm just basically trying to scribe those holes where they are onto the cardboard. One of the things I needed to know was where the bottom of this thing was. So with the nut off, I was able to mark where the bottom was, and then where I think that what we're calling the nub here, where I think that will fall on the piece of paper. So it looks like it's going to be about 3/16 of an inch higher than the center of where it is right now. So I just kind of moved my little speed square over, and I marked it on the cardboard close enough. You know, it's just going to be a rod end kind of going in there. We want it to be pretty close, but if it's off by 1/8 of an inch, no one will ever know. And then now that I got all those things down there, these are the critical pieces of making the mount. So I can measure the distance between these 3 holes, and then where are those 3 holes in relation to this line. So now we can take these 3 holes, we can measure the distance, where those holes are in relation to that center line. And then the other piece we need is the height of this line right here in relation to the center of the slider. And now we can back out the dimensions to make this mount. Let's go ahead into Fusion 360, make the mount. All right, so I do a bunch of CAD right here. It tends to take a long time, so I will put the complete unedited version right at the very end of this video. All right, so I dropped the program into the Langmuir Systems Crossfire XR, and this is the machine that makes all this stuff, for me at least, possible as far as cutting the parts out. And if you think this is something like in your own shop, check out the link in the description below, which will take you to the Langmuir Systems website to purchase one, or code NTDRacing will get you $100 off for one of the Crossfire Pros or the XR. I found the file for the pitman arm that I made for Honcho, which has worked for a long, 3 years now. So I just took the same file, modified it slightly, and I'm going to cut out the same parts for Lefty. After they're off the plasma table, I drop them into a white vinegar bath, which breaks down the mill scale. And then when that's done, I rinse them off with some fresh water, let them dry, and then I hit them with this bristle brush by 3M. Also, there's a link for that in the description if you're interested in one of these. I think it does a great job, I think better than a flap disc, of taking all the mill scale off of the plate metal. Okay, with the mount piece in place, I'm going to make a bend right here, and I want this bend to be about 50 degrees. I got to give it a little bit of room to make the bend in the press brake, but I'm probably going to make the bend right about here is where I'll put it into the press brake. And I'm going to use this line right here to ensure that I have a 90-degree bend in the press brake. I want it to bend 50 degrees, which means I got to bend both sides up 25 degrees. I'll be using my angle cube to make sure I nail that 25 degrees of bend. All right, here's a quick look at the steering, right before I get the steering box mounted in there. What you see is I mounted this plate. This is a 3/16" plate, maybe a little bit overkill, I don't know. But to put this thing in there, you can see I did some rosette welds in the middle, and then it's welded underneath over here. So this plate basically ties in the front bumper. It ties in the whole 4x4" square tubing down there. It ties in these lower A-arm mounts, and then it also comes all the way back inside here, and you can kind of see where it ties in and gives a little bit more rigidity to this whole steering bulkhead, I guess we can call that. But besides that, now what we're going to do is we're going to locate the steering box. We can go ahead and take a look at the parts we have over here. I guess we start with the pitman arm. This is what the old pitman arm used to look like, and now it's a steering nut. And how that will basically go is this will be the top. It'll weld onto there. This will be what will be the bottom, which will basically allow the nut and the washer to fit inside there and mount. And then these will just be some brace pieces. I'll probably cut and bend those around the radius to really give those some rigidity. This is the same one, basic shape that we used on Honcho. These holes had to be made just slightly larger to accommodate for a slightly larger bolt and shaft that comes out of this steering box. So the steering box over here, you can kind of see where we made this bend. These are temporary. I'm going to make some additional doublers for these. We found on Honcho, the only place we ever had a steering failure was one of these things tore out from when one of our dudes, I don't know, hit some pretty big stuff, tore that thing out. But besides that, that should be pretty good. And then I'm going to run a 2x2" square tube up here, and then it'll go all the way. I'll show you where that's going to go. It's going to mount the whole plate will kind of go this way with the kickstand over here. The 2x2" square tube will go here. It'll go straight up, and I'm going to go ahead and put another piece of plate up in here to kind of give that a little bit of more rigidity and tie all that stuff together. Let's get this thing in there. All right, I think that we're at the point now where we can call the steering complete. Let me show you kind of what we did and some of the fabrication that maybe took place while I wasn't on the camera, and you can kind of see how it went in. But really, it was all just kind of like the same CAD, wash, rinse, and repeat. And if you want to see the full version of the CAD as I made this plate right here, you can wait here for about a minute, and it'll be at the end of this video. But some of the key features here to hopefully the success of this steering system is not only this big plate, you see this kind of big kickstand here that's going to kind of help this thing tip over, but really this tube right here, this is a 2" square tube with 120 wall. And it is mounted. You can kind of see how it's welded up there to the top. This is just a square plate that goes on the top of this whole thing. It's going to create some rigidity for the whole system, but mostly for the steering, just not letting it not get knocked over as it takes a huge load over here from one of the tires or something like that. And it's obviously welded down there to the bottom. I did put a 1.5" 120 wall tube right here, and this is where that other bolt goes in there. Two reasons. One, it reduces how much this tube is weakened by this hole right here, but more importantly, it keeps that bolt from falling down inside there when I try to put that thing in there, so it slides in there nicely. I'm going to spin over here real quick, and I'll kind of give you a little demo on how the whole steering setup works. The only part that is really missing right now is some grease and the boots that we're going to put over here, but I'll put those on right at the very end. But you can kind of see now, let's say I want to turn this, let's say I want to turn the truck to the right. I turn the steering wheel to the right. It pulls that pitman arm and then makes that slider go to the right. And if I want to go the other way, obviously the opposite direction is just going to be pushing this little tie rod right here. So there you go. So this thing is pretty much complete. You can see I've got other projects going on. I just made the video also for how I'm making this lower suspension A-arm. I'll be making the upper suspension A-arm next. We got the 14 bolt over here. We did a re-gear. We put a spool on it. I'm trussing it. We got videos for all that coming out also. So if you want to see this stuff, hit the subscribe, please. It definitely helps us out. And ring that bell. You'll get notification of future episodes when we do stuff like that. So all right, one more time, thanks for watching. If you want to see the full CAD for this thing and see how I basically made this steering box fit up to that plate perfectly the first time, stick around. We'll see you next week. Take care of yourself. All right, this time I think the audio will actually work. So here we go. We're on Fusion 360. And if you're new to this, I always try to go through it as if you've never seen Fusion 360, you're learning how to use it. So apologize if this is some simple stuff, but we are going to draw something such that we can cut it on the Langmuir Systems Crossfire XR. And if you look over here on the side, this kind of gives you the planes. X and Y is what all the plasma cutters cut on, and then the Z is usually your torch height control. So as we go over here and say we want to sketch, I'm going to sketch on this plane, which will draw this thing on the X and Y. You could change it later, but it makes it easier just to start on the correct plane. So for this thing that we're making, I'm going to basically work off this center axis as my 0 point. That'll kind of help out as we kind of go through this thing. And I'm going to start with just basically this first hole, which is the very top hole, and I'm going to anchor everything else off of that. And that top hole is 9 inches from the bottom. So I'm going to go over here to the side of the pane over here, and I'm going to click on what's called construction lines. And construction lines are lines that will not be cut when we do put on the Crossfire XR. So it'll be kind of a dashed line, you'll see. And as I'm going to click here, I'm going to draw a line straight up. And that first hole from the base where it's going to mount all the way to the top is going to be 9 inches. And actually, I'm going to put a 3/16 inch plate in there. So I got to change one number here while we're doing it live. Let me see. 9 minus 0.1875 equal. So it's going to be 8.81, we'll call it. This will be easy enough there. And that's where that first hole is going to go. So the bolt that I'm using for this, as it turns out, is the exact same bolt that they use on the Chevy Silverado brake calipers as far as the pitch goes. If you're looking for one of those, about like $5 at Rock Auto or something like that. And they are 0.63 inches in diameter. I'm going to use 0.68 just to give me some wiggle room. So I'm going to hit the hotkey C, and then I'll put a circle there. I'm going to go over and turn off construction lines because I actually wanted to cut this one. So 0.68 inches will be where that hole is. Now the next hole, this is where we're going to work with a triangle. So cool thing about triangles is they got 3 sides, and as long as you know the dimensions of all 3 sides, then it all works out. So I'm going to hit hotkey L. I'm going to go to the center up here, and I'm going to start making this line here. Again, construction lines back on. And that length of this line is going to be 5.294 inches. And then the other part of it is, again, to make this thing true to that center line, we took the dimensions, and it's 28 degrees. So it looks like it's making me add 90 degrees to that. 118 degrees is going to be what will basically orient that that line to make the whole case stand or sit true and make that basically the shaft be vertical. There, I'm hit enter on that, and that's going to locate the location for the next hole. I'm going to hit hotkey C, and I'm going to turn off construction lines, and I'm going to say 0.68 inches for that. Now these points right here, I actually want to make sure that they don't move. So you can actually hover over them. You can right click, and then I'm going to say fix. I'm going to fix that location of that hole. I'm going to do the same thing with this one over here. I'm going to fix the location of that hole because the next operation, I don't want those holes to move. And so I know that the next line is going to be hotkey L, construction lines on. The next line is going to be 5.386 inches long. And I'm just going to put that out here in space. That's going to look kind of weird here for a second. But then this line at the bottom here, hotkey L, snap to the center there. This one is going to be 5.81 inches long. And you're like, man, those two aren't those two together. What I can do is I can go over to the constraints, and I can say I want these two things to be coincident. And I'm going to say I want this point right here to be coincident with that point. And that's going to go ahead and complete that triangle. And since I fixed these points, it didn't move those around. So now this is the location. I'm turning the construction lines on, hotkey C. This is going to be the location of that third bolt hole. And again, 0.68 inches. And now you can kind of see, yep, sure enough, that's a weird triangle. And if you didn't kind of do the math this way, it would not have oriented itself. It made it such that the shaft and the pitman arm would basically run perpendicular and parallel to the base of this thing. All right, from there, we got to make the rest of this plate. So at the top, I'm going to hit hotkey C again. Construction lines are off. And I'm going to make a circle right here that makes the top of this plate. It's going to be 2 inches. And then these down here, I'm going to make a 1.75. So hotkey C. This will be 1.75 inches. Hotkey C. And 1.75 inches. Cool. All right, now we got those. Now we're going to just do a little bit of connecting the dots here. I'm going to draw a line, and it's going to go from this point over to here. And what I'm going to do is I kind of move this thing along the line here. You can kind of see it makes this little symbol right there, and that's telling you that that line is going to be tangential to that one. I want it also to be tangential over here, so I can kind of turn on the constraints over there and say click on that line and the circle, and then to make it tangential to that. And that'll just kind of make it a smooth transition around there. I'm going to hit hotkey L again for the line. I'm going to do the same thing over here. I'm going to say this to that tangential, that lock in that one, and then I basically got to make that one tangential also. And then from there, I'm just going to come straight down from this circle. So hotkey L to the base, which is going to be down here. And I'm going to lock in a constraint of perpendicular. Yeah, it's at 90 degrees, and it's snapped on that line, so that should be pretty perpendicular. And then I'm going to continue this line just over here in space. It's not going to make a lot of sense just yet, but it will in a second here. And I'm going to hit escape. And then I'm going to make this line tangential to that line. There, and that's going to be, you can kind of start to see the shape of this bracket that we're going to end up making. And then from here, what I'm going to do, I'm not going to make the bracket come straight down. What I actually want to do is I'm going to say hotkey L, and straight from this point, I'm going to go out here, say 6 inches. Makes it about right. So 6 inches. I'm making this up. And then I'm going to say hotkey L from here. I'm going to go up here, crazy lines, and then let's just go right to there, like that. And let's soften those lines up a little bit. There. We'll say, make it look like that, and then enter, and then another radius from this one to this one. Let's do it like that. Enter. All right. And now this is kind of how this bracket's going to look. Like you're asking, well, why is that point right there? So this is where this whole thing is going to sit, and this is where it's going to run off the edge of one side of where it's going to mount. But over here, I got some room, and what I'm going to do is I'm going to put this whole piece of 1/2-inch plate in my press brake. I'm going to bend it right here, and that's going to basically give it more like vertical rigidity. So I'm going to put a bend. It's going to weld all the way right along this, and there'll be a bend right here such that it kind of almost has some little stand to sit on. So that's what I'll do with that. Now what I'm going to do is got to go in here and cut some lines. I'm going to cut all those lines. I'm going to cut all these because that's not something I wanted to cut. And then cut these lines. Oh, I didn't want to cut that line. Let me see. Let's Control Z until that line comes back. We'll come back and cut that line. Oh, I didn't want to cut that line. I want to cut. You know what? Yeah, that's there. That's right. Cool. All right, there's our part. That's the part we're going to cut out. Now what we'll do is we'll hit hotkey E until I want it to extrude that. It's going to be a 1/4-inch plate. And there is our part. You can kind of check out what that's going to kind of look like. Now, what I want to do is the way that I cut things in my plasma cutter is I kind of start the top left, the bottom right. And so when I do the CAM part of this, the computer-aided manufacturing, I don't want it to cut like this and leave a huge space up here. So what I'm going to do is I'm going to hit hotkey M. I'm going to select this body, and I'm going to tell it, I just want you to rotate this thing all the way over 180 degrees and hit enter. And then now what that'll do is it'll make it such that when I do the go from computer-aided design to this computer-aided manufacturing, CAD to CAM, and I say setup, and I select this point, and that's going to be the point I zero out on my plate of 1/4-inch steel so I don't waste too much over there. And I'm going to call this, so this is the box point, and I'm going to go ahead and call this the steering box mount. All right, so we got that. That's the setup part. Now we're going to go tell it to cut. We're going to select. And if you are interested in one of these tables and you're like, oh, should I go with the Hypertherm or should I go with the razor weld? I'm here to tell you, I officially have, my luck might change if I change my plan. I keep saying it. As soon as my razor weld goes bad, I'm buying a Hypertherm, but I have had 2 of these and they both were awesome. They never went bad. I'm going to cut at 55 inches. Those holes are pretty big. I'm going to enter those holes, let's say at about 35 inches per minute. And I want to exit pretty fast, let's say 65 inches per minute. I'm going to go up here and select this part I want to cut. Then I'm going to come over to this last tab and I'm going to say 0.05 inches. My lead in will be at 90 degrees. And those holes are 0.68, so let's go with a 0.35. That's gonna be a big lead in, but that way it's cutting and it's establishing that cut before it, it's gonna be totally establishing that cut before it hits the circle, is what I want it to do. So, and I want it to lead in right here. And the reason that I pick a lead in right here is because I want it to come over here, maybe a little bit further down. Let's erase that lead in a little further down right here. It's going to do its lead in. It's going to cut. It's going to cut right down the edge of that plate. It's going to cut down the other edge of that plate, and then it's going to cut down the thick part of that metal. What I want, let's say I started over here, then what would happen is it would go down this really thick part of this sheet of metal. It'll come all the way down here, a whole bunch of thick part of the sheet. And then it would get over here, it would be disconnected from the thick part of the sheet. And then it would be basically held on by this little tiny thin sheet, and it might move a little bit. So by starting over here, and it's going to kind of cut this way, what that will allow it to do is it'll stay connected to the big piece, which is kind of helping it hold its geometry. And then it'll make It'll make this cut first, the thin piece, and then the whole time it's doing this cut, it's still connected to the really firm big piece of metal. So let's hit OK, and let's see if it actually made the circles, and it did. And here's again something you got to look out for is you see how big I made these lead in. So it's going to fire the torch here, and it's going to drive all the way in. If I had made that lead in, let's say 1 inch long, then it would try to fire the torch all the way out here, which basically means it wouldn't make this cut path. So when you're looking at this, you want to make sure that all your holes have a cut tool path on there. So, and they do, so that looks all good. So I'm gonna go create G-code, 1/2 inch plate steel. I find that if I give it a 0.3 second pierce delay, that works a little bit better for the 1/2 inch. I'm gonna say post, it's gonna go ahead and post it right to my steering folder, which I had there, I should point that out. And now we can go to the Langmuir Systems Crossfire XR and cut this part out.